Hello friends, welcome to yet another video of Hindu Judaic. We will talk about India entering the big league, $40 million export to Armenia, SWATHI Weapon Locating Radar. In March 2020, India and Armenia signed a deal for the sale of 4 SWATHI Weapon Locating Radar stations. This deal, worth $40 million, was the first of its kind with Armenia and stands out because vendors from Russia and Poland were also in the running. A WLR is designed to detect the trajectory of an artillery shell. Using the detected path, one can narrow down on an enemy artillery fire base and direct return fire to successfully destroy it. The SWATHI WLR has been designed by the Defense Research and Development Organization's Electronic Research and Development Establishment Laboratory and produced by Bharat Electronics Limited. The SWATHI WLR is a derivative of the fire control radar system used on board an Akash surface-to-air missile. While testing the missile, engineers observed that the Akash FCR could also track artillery shells being fired in a range nearby, and therefore used the same design while developing the SWATHI. The first working prototype was ready in 2004 as part of an INR 20 crore contract issued by the Ministry of Defence in 2002. In 2008, the Ministry of Defence ordered 30 SWATHI WLR as a part of INR 1600 crore contract signed with the Defense Research and Development Organization and BEL. The radar array is designed to detect and track incoming artillery rounds, mortar rockets, and the launchers. It can also provide fire correction by tracking friendly counter battery fire. Large caliber artillery rounds can be tracked from a distance of 30 km. The WLR utilizes a C-band radar with a frequency range of between 4 to 8 GHz and a wavelength span of 3.75 and 7.5 cm. The radar is mounted on an 8-wheeled Tatra truck, a vehicle that has multiple uses in various departments of Indian Defence Forces. The SWATHI WLR is a passive electronically scanned array radar, which means that the beam can automatically lock onto a target without having to move the transmitter. The transmitter receiver is fixed, and so is the antenna. The SWATHI WLR has an azimuth range of -45 to +45 degrees and an up-down slew able range of 135 to +135 degrees. The radar can track rounds fired at both low and high angles and at all aspect angles from behind or towards the radar, or at an oblique angle to the array. This change in direction takes only 30 seconds because it's done electronically. The radar is of a coherent type, which helps clear out the background clutter. This capability is achieved via the CFAR, constant false alarm rate, which sets a threshold for how weak or strong a received signal should be, thereby reducing the risk of a false alarm. The resolution of these signals is improved using pulse compression. The high-power signals are generated with the help of a traveling wave tube, which is an oscillator with protection from power surge and integrated cooling systems. The SWATHI Weapons Locating Radar can operate between temperatures of -20 and +55 degrees. The onboard map can store a map spanning 100 × 100 km with locations of up to 99 tracked targets. Up to 7 targets can be tracked simultaneously. The radar is designed to be fully operational within 30 minutes from being set up. Interestingly, while designing a copy of the ANTPQ-37, the Chinese noticed that the radar's accuracy went down in hot and humid conditions. This became worse when operating in a coastal region or in an area prone to heavy showers in the monsoon. Another limitation of the ANTPQ-37 was that it had a difficulty tracking shells following a flat trajectory. Compared to the Raytheon-built ANTPQ-3637 series, the SWATHI WLR can operate at a much higher altitude of 16,000 feet, making it perfect for deployment in the LOC and the LSC. Clearly, with one of these sales, India has entered the big league of countries exporting military weapons. Friends, hope you like this video. Please subscribe us for more such videos. Thank you.